In this video, I'm going to give you your first introduction to the chemical formula. This is the language of chemistry. It's something that is kind of difficult for some students. If you keep good notes and you keep a good cheat sheet with you, you're going to be just fine with this. It's just like any other language, right? You have to use it for a while, frequently, before it sinks in, and you learn that new language after a long time of using it over and over and over again. So the first time you use a new language, though, it feels really weird and it doesn't make much sense. So that's normal, and you should know that that's probably how it's going to feel for you when you first start learning this new language of chemistry. So here is an example of a chemical formula that I wrote, and there's several things in here that you might notice that it tells us, okay? Basically what a chemical formula tells us is it tells us what elements are in a compound, okay? Okay, so we have a chemical compound. It gives us the ratios too, right? Like with these little numbers, you can see how many atoms of each element there are in a unit of this compound, okay? So the little numbers, first vocab word from this, those are called subscripts, and they come after each element, okay? So this formula tells me that I have 2 nitrogen atoms per unit, and you're going to wonder, where did that 2 come from? Maybe you see it already, maybe you don't, but I'll get to it in a moment. There are 8 hydrogen atoms, that's the H. We've got 1 carbon, and we have 3 oxygen atoms in this formula, okay? So what this is saying is, in this compound, which by the way is called ammonium carbonate, we'll learn about naming later, I'll teach you that in another video, but ammonium carbonate, each formula unit of ammonium carbonate has 2 nitrogen atoms, 8 hydrogen atoms, 1 carbon, and 3 oxygens, okay? The 2 comes right here because there are these parentheses, okay? This 2 applies to everything in parentheses before it, because you see the 2 and the parenthesis are right next to each other, okay? So you have to pay very close attention to what's the next door neighbor of each of those little subscript numbers. Okay, so this 2 again refers to everything inside of there. So N has no subscript right here. That means 1. There's 1 nitrogen there. And then we're going to multiply that by 2. Okay, so 2 times 1 equals 2. Hydrogen has a 4 subscript. Okay, but because of the 2 outside of the parentheses, that's going to be 4 times 2, or 2 times 4, I'll write it that way, and that's 8. That's how I got the 8. Now carbon, not in parentheses, no subscript right there. Okay, so that means 1 carbon atom. Oxygen, not in parentheses, subscript of 3 after the oxygen, so that's 3 oxygen atoms. This counting that I'm doing, this is something you're going to need to practice. It can get complicated occasionally, but that's how that works. So continuing on, you can pretty easily figure out these next 2 formulas. This has 1 carbon, 2 oxygens. This has 1 carbon, 1 oxygen. But the last thing I wanted to take a look at is connecting back to what we know about chemical bonding. Right, there's 2 kinds of chemical bonds. There's covalent bonding and there's ionic bonding. And each of those has formulas. There are ionic compounds and there are covalent compounds. And there's a way you can tell which is which. Now maybe you remember this, maybe you don't, but with ions, right, it's always the metals doing the donating, and it's always the nonmetals doing the accepting, because the nonmetals almost have 8 valence electrons. The metals usually just have a couple of valence electrons, and so they can donate them to the nonmetals. So whenever you see a metal in the beginning of a formula, that's an ionic compound, and that's how you tell. Okay? Starts with Mg. If you go and find magnesium on the periodic table, you will see it's about right here in the alkaline earth metals. Okay? It's a metal. And that means that magnesium chromate is an ionic compound. Okay, this is the magnesium metal donating to this anion, and I haven't talked about polyatomic anions yet, but this is what's doing the accepting, this is what's doing the donating. Okay, the point is, it starts with a metal. That's what matters. CO2 starts with C. C is carbon, and carbon is a nonmetal. Okay, carbon is not donating to oxygen in this compound. This is a covalent compound, right? This is two nonmetals together, carbon and oxygen sharing. Okay, this is covalent. We also say that it's a molecular compound. That's a different word for the same thing. Okay, so CO2 is covalent or molecular, same thing, they mean the same thing. Okay, CO, two nonmetals again. Okay, C, nonmetal. O, nonmetal. When two nonmetals get together, they're sharing, right? Nonmetals don't like to donate. It's not ionic. Okay, CO is molecular. CO is covalent. Same thing. Okay, and that's a nice brief introduction to formulas for you. Okay, so you'll get some chance to practice in class, maybe in some assignments. That counting part you definitely want to practice, and the second thing you need to practice is, can you tell which ones are ionic and which ones are covalent?